Welcome back, everyone, to a brand new episode of LLM News, where I cover some of the most recent and most exciting developments around LLMs and the world of AI. The first in the list is this interesting recording or episode from Dwarkesh and Leopold. Leopold was a former OpenAI employee and he was working a lot on alignment. So they go into discussion about this idea of $1 trillion cluster and why that matters, and a lot of other ideas around AI regulation and also the global scene around AI. So I think it's an interesting discussion. And Leopold obviously has a lot of interesting thoughts about what that AGI path looks like. You may agree or you may disagree with his thoughts and his ideas, but I think it's worth checking out and always look at ideas that others may have in the field. And so I never kind of disregard anything that a researcher is talking about. So I'm always very curious about other people's perspectives on the technology and where AI is going. He also posted an essay series. He put together some ideas on the AGI strategic picture. And again, AGI could mean something different for different people. I also have been very opinionated about why AGI is somewhat of a distraction in some ways, but I think we should be open to different perspectives and kind of learn about how others think about the space and where things are going. And I think these opinion pieces, they really matter as well, and you could never disregard what other ideas people are sharing. And so my opinion about this as it stands today is that I think we should definitely look and listen to what other people, especially with people with different backgrounds, are saying about the field and where it's kind of going and what's kind of the progress in the coming years. So it's all about that here. It's called Situational Awareness, The Decade Ahead. It's a PDF document, very long document. You can take a look at it, and it goes into discussion about the path to AGI, what may be needed, right? Things to kind of be very careful about and so forth, right? Next up, we have this new release. It's a DIT video AI generation model called KLING, and it's open access. It generate 120-second videos with FPS 30 and the quality 180p. And they claim it understands physics better, has model complex motion accurately. This one, you can see this is the prompt for this video that was generated by this model. Now, if all of you have been tracking all the developments, especially from companies like OpenAI, or they announced this new model called Sora that could generate these longer form videos, and it's all generated by AI. So I think it's along the same lines, and it looks like it's a good competitor from what I can tell. You can see the quality of this is really good, and I mean there's claims that it understands physics better. So that's one of the kind of issues we saw with the Sora models. So that's great. This was making the headlines, and I wanted to cover it here. So this is the page here. If you want to learn more details about this model and what this whole project is about, I will leave the link in the description. So here it is, KLING, Make Imagination Alive. There are a lot of little videos here that you can play. This is really good quality from what I can tell. This one is interesting. It has like a reflection, so it's reflecting, what could be in the background and so on, and that's really cool. And this one is a video of a parrot. Somehow parrots are concepts to visualize in some of these video generation models. So that's really cool. There's a little bit more details here about what it can do. It claims that it can generate up to 2 minutes long videos. That's kind of exceptional at this rate of 30 FPS. I mean, look at this quality. It's not quite there yet if you compare these videos with those generated by Sora. We have seen a lot of progress, and I know there's a lot of open source initiatives as well to get something, at the level of quality as Sora. So it's quite exciting to see these developments and other companies competing in this space. You can see that there are a lot of examples here. And then there's this really interesting example that I saw. So this is more about the experiences, right, and applications that you can get from these models. So for instance, if you provided some kind of photo and then you give it some template actions that you provided, you can get it to display the same motion in this template. That's really amazing. And you can see, I guess this video generation model can kind of understand these bits of information as input and generate this. So it is what is exciting about this whole space. Can you imagine now that you can do this for generating entire scenes, right? Where you have multiple characters and you can just kind of just provide the original photo maybe of a character that you're interested in, and then all of that is kind of visualized and animated for you. That's really powerful. I think creators, I think, can benefit a lot from this type of tools, especially folks that are doing animation and video creation. Next up, we have this impressive paper by OpenAI. If you have been tracking this space, there is a lot of interest in interpretability and explainability. The reason why it's so important is because understanding the internal workings of these systems, these frontier models, these large language models, as we know that these models come with these limitations, these issues of steerability, it's really hard to get them to generate predictable outputs. So by understanding their internals and maybe understanding the features that these models learn, maybe they can help to steer like the outputs that we're getting from these LLMs better and to make them safer at the same time. So we saw a couple of weeks ago the introduction of a work, very similar work by Anthropic, which is also focusing on safety, where they developed this model that can extract large amounts of features, right? Features that represent like emotions. They even discovered like safety type of features or safety related features. So it's along the same lines. The approach that they use is basically they try to develop a method where they have this sparse autoencoder that can be used to represent 16 million interpretable patterns. So there are all these features that can be discovered and can be represented by this sparse autoencoder proposed by OpenAI. And there's a paper for it here if you want to learn the details. But I think this is an interesting announcement, I believe, and I think there's going to be some open source efforts from OpenAI around this type of work, because I think when you think about the application of LLMs, right, a lot of the time it's going to be trying to make sure that these models give you like reliable outputs, give you safe outputs as well, outputs that are not going to harm your users. So having an understanding of what concepts these models are learning, right, really hard task. A lot of researchers are spending a lot of time on this. And so what they have done is they provided some examples here on this method that they're proposing. And they also speak about why this is challenging, why a lot of work has been done around sparse autoencoders, but they were not able to kind of scale that. And they introduced some ideas to scale that, to do these analysis and these interpretability work with some of these frontier models. And interesting enough, they provided some examples. Now, in my opinion, I looked at the examples, and some examples are clear, some examples are like, okay, maybe they are kind of subjective, but I think it's a really good kind of progress. They say that to check the interpretability of features, which is kind of one area where they found it challenging, they visualize a given feature by showing documents where it activates. So here are some documents. They are explaining the features that they are seeing, kind of like patterns. I guess they're doing this kind of manually. For instance, they have this human imperfection. It's a phrases relating to things, especially humans being flawed. And there are all these documents that they provide as examples where they see a lot of high activation, right? And they explain this feature. So if you click at the link below that they provide, they have like a really nice tool where you can go and see more examples. So you can see that these ones at the bottom here, where we're getting really high activation, right? All of these examples are under the same theme, which they explain here, right? In this theme of phrases related to things being flawed, right? Especially humans in this case. If we can do this and if we can understand how to spot these features, right? And when these activations are happening, right? I think it can give us kind of a way to steer these models better, right? So we can anticipate, for instance, where we're seeing kind of maybe things that are more related to vulnerability, and we can take more precautions around those type of outputs. So I think it's an interesting work overall. I like this little dashboard where you can kind of go and show more examples, and you can see that they give you more examples. And it does seem like where we see these high activations, it does seem like there is kind of some pattern, as they explain, right? They explain that feature. But this is really hard, right? Because I'm assuming that in some effort here to spot these type of patterns and so forth. So there's also this kind of human effort here. And I'm not sure that this can scale today, but they also explain that here, obviously, with the limitations, right? Why it's difficult to scale this type of work. They want to scale this to the bigger models. In the future, we may have even bigger and bigger models, like maybe models that can scale up to like be trillions of parameters. But how do you scale something that can extract billions or understand trillions of features as well? That's really important. And so I like this line of work because I think interpretability doesn't get a lot of attention. And I'm noticing that some of these companies are spending a lot of resources to develop methods to better understand these models, these frontier models. Next up, we have Mistral AI. They made an announcement on their fine-tuning services. So they have different ways. I think a month or so they announce like their library. There's an official library as well that you can use to fine-tune models or fine-tune their models, their Mistral models. And they're also kind of providing this as a service as well, which is kind of interesting because this is very similar to what OpenAI, right, being an LLM provider, they provide as well. So OpenAI has this kind of fine-tuning service that you can go and you can upload data sets and you can fine-tune your own models and you can use those models in the playground as well. This is what they're kind of proposing as well. So I think it's a great move. A lot of folks are interested in kind of exploring fine-tuned models. Fine-tuned models, are still useful. They're useful for many different kinds of applications and tasks. So I think this is exciting to see. And they built their code base, as I said, on the LoRa training paradigm. So LoRa to make it more efficient, and also at the same time making these models, not forget knowledge and make sure they're competent and they can scale well in terms of performance. They have this serverless service that they're proposing, the fine-tuning service, and I think it's available to use. So you can just register on their platform, and you should be able to easily have use your fine-tuning services. And this is great because you may not want to deal with all that infrastructure work, and you may not want to manage all of that stuff, right? Servers, whatever you may need to serve these models. Then you can just use their platform. Interesting enough that they only provide this now with the Mistral 7B and Mistral Small. So I think we also need access to the bigger models, but obviously with the bigger models, there is obviously bigger challenges like with OpenAI, right? I think initially you didn't have access to fine tune like the biggest models, only the smaller ones. So I think it's the same here. So it's a lot of compute resources and so forth. So it's a good experiment, I think, and we'll see how the community adapts to this. Next up, we have this paper that was published in Nature from Meta. This is the NLLB team, No Language Left Behind team. I'm very aware of the folks that work on this project, and they published finally this paper on Nature. The idea is that they want to build this kind of universal translation system, and they show really good performance with the architecture that they're proposing. They're using a sparsely gated mixture of experts architecture. You can see that these mixture of experts are being used everywhere. They also propose a very interesting way of evaluating as well. Keep in mind that there's not a lot of data around a lot of the languages in the world, right? They mentioned that here. Like when you get bilingual data, for instance, you could get data from English, Chinese, Spanish, and so on. But then you have this kind of long tail of languages that where we don't have that amount of data. So I think this is a breakthrough work and something highlighting, because I think these translation systems, right, can enable all sorts of AI application and experiences. So for instance, if we were building agents, right, and these agents can serve a certain population with certain language support, it'd be interesting to see if we can enable these agents with this kind of machine learning models that do this type of translation, universal translation, and have that support and that capability. It's more about building this neural machine translation system. And so very excited about this. Check out this benchmark here. It's very interesting that they put together. A lot of work went into this, and some of the ideas and how they evaluate this work. If you really want to take a look at kind of the groundbreaking work that's happening in neural machine translation, I think this is one of the works that you really want to take a look. There's a lot of references as well, important references mentioned in this paper. So take a look at this. I think it's something worth kind of spending some time understanding and studying. Next up, we have this new paper from Trudeau and Albert Gu. They propose transformers are SSMs. We have heard a lot of interest in this kind of alternative architectures to transformers, and there was a release of the Mamba model, which was Mamba-1, and these are the same authors, I believe, and they're proposing a new architecture called Mamba-2, where they're trying to combine like the lessons and learnings from these attention mechanisms and these state space models, right? So that's kind of the idea of this work. There's a lot of like math involved in this paper, and you can take a look what are their ideas. But essentially, it's like doing the theoretical work and understanding those efficiencies and how they can use those efficiencies, right? Not discarding what has all the work that has been done with transformers, and kind of leveraging those attention mechanisms, but how to leverage them in a more efficient way. I think this is what this work is about. They show a lot of results and so on. But if you're interested in kind of this trend of research where the objective is to build more efficient architectures for training these large language models, you will really like this paper. So it's a very long paper, again, with a lot of like maths and details. But if you look at the conclusion here, you can see exactly what they're trying to achieve. And again, this is the Mamba-2 system. And I guess it's more efficient, got good results. Otherwise, they wouldn't really post this paper. But you can check out the results in the paper here. But it's trying to kind of, again, merge and combine all of these ideas, right? And they've kind of found from their analysis and theoretical work and really efficient ways to leverage both worlds, right? These different types of architectures to build something where they can advance the efficiency of the systems and also at the same time getting really good quality, obviously, from the language models. Along the same lines, I posted this summary of this paper came across. It's MatMul-free LLMs. So we know that matrix multiplication, right, has really scale the need for GPUs? Is there a different way on how we can train these models and design these systems without us needing so much computational resources? That's really the question that they're attempting here. And very important at the same time, making sure that we don't lose the benefits that we're getting from the MatMul type of LLMs. So that's the idea here. And there's a lot of details in the paper. So this is the paper here. I'll provide the link in the description. I think it's a great work, and it's very similar to the previous one I covered, where it's about modifying the architecture and trying to scale and making sure that these models can be efficient, right? More memory efficient during inference, because we want to put these models in production and we want to make sure that they're feasible, right? And I think inference is one area where a lot of people are focusing on, not only in research, but also in the industry. And so it's really exciting to see this type of results and this type of papers. But yeah, matrix multiplication being free for that, meaning that knowing that matrix multiplications can be quite expensive is really an exciting, I think, idea. And so they claim that they provide a GPU-efficient implementation of this model, which reduces memory usage by up to 61% over an optimized baseline during training. Now, I haven't really looked at all the details of this paper, but this is kind of crazy that we're getting 61%. Utilizes optimized kernel during inference, and the memory consumption can be reduced by more than 10x compared to unoptimized models. That's also very impressive. Again, take a look at the work, what they're trying to do here. And I like all of these papers. This is something that I'll be highlighting throughout these LLM news episodes. Next up, I have two papers, which is they're trying to, again, make these models smarter in terms of reasoning, right? Because we know that these models, when we use them for more complex applications and complex tasks, there's always these issues of, they make a lot of mistakes, they hallucinate and so forth, which could be really not great for applications, especially high-stake applications. So this one, they present SaySelf, a training framework to teach LLMs to express more accurate, fine-grained confidence estimates and self-reflective rationale. So they're using this idea of self-reflection. They're generating those self-reflection, creating a data set on that, and via that, try to enable the model to, be more, I would say, more calibrated and can express confidence more reliably through these self-reflective rationales. They also use reinforcement learning and it's applied to calibrate confidence estimates, encourage the LLM to produce more accurate, high confidence predictions, and penalize overconfidence in erroneous outputs. So yeah, it's a combination of ideas, right? And I think self-reflection is something that a lot of researchers are spending more time on and trying to figure out how to sort of integrate and improve that type of prompting methods and make them part of kind of the training of these models natively so that we can get more reliable systems. And in this case, again, it's about allowing this system to be able to express right confidence in any task it performs. So the paper is here. All the details are here. I think also very kind of cool paper. It's less about, oh, we have a really fancy prompting method, and more about, okay, let's kind of use all these ideas and see how we can kind of mix it and come up with something that can improve, kind of fix some of these issues or mitigate some of these issues that we're seeing with these LLMs. And in this case, the issue is that these reasoning chains, right, if you're doing them in one shot, they might not be reliable, but if we can kind of measure that, have a data set to fine tune the models on that and have a better approach to make sure that this model can have and express and elicit that confidence, I think can improve the model overall. That's the idea here with this paper. Next up, we have this announcement of the FineWeb-Edu. So the original announcement was here, but Karpati kind of chipped in with some ideas on why this work really matters. FineWeb was released, I think, a few weeks ago. Nice blog about it that talks about this FineWeb, where they're trying to refine data sets, provide their large scale data sets to train open source models, right, with these large scale data sets. And they're focusing on obviously on ensuring that these data sets are high quality. What they are proposing now is how can they keep trying out different ideas with this data set now that they have created it, right? Because we rely a lot on this common crawl and these other data sets that has a lot of noise information. And this is what Karpati is saying, right? How can we filter out those data sets and make them of higher quality? And in this case, as the name implies it, of the data set, they're focusing on high educational quality data sets. And interesting enough, they're using an LLM, Llama-3 70B, to rate the quality of those data sets or those examples. You can see that they have 1.3 trillion tokens. Some more ideas here from Karpati, his thoughts on this. I agree with most of what he's saying here, that once we can find really reliable methods to figure out what's the signal in the noise here, because a lot of these data sets contain a lot of spammy information, right? And all of that is being used to train these models. So I think if you are building safer models and you want to build really complex systems with really complex capabilities, I think it's important to focus on making sure you have good, high quality data sets. Even if you're just fine tuning or if you're pre-training these models, for both phases, it really matters. And so he also talks about kind of thinking about how to use pre-training data sets as well for fine tuning, which I think is a great idea as well, because there's a lot of these issues that emerge when fine tuning models, right? The knowledge may fade away, or how do we maintain that, right? How do we maintain what we get from a pre-trained based model? And when we fine tune that model, that we don't lose capabilities, don't lose the knowledge that model may already have. And to do that reliably, it's a really difficult task. So I think the idea of ensuring the high quality of a data set can really be a good method to address some of these issues. Next up, we have this tweet from .txt AI Twitter account or X account. And they're doing really interesting work around structure generation. This is something that I discuss a lot on Twitter and my courses that I do, my live trainings, where we figure out or try to figure out what are the kind of best methods to prompt these models, but also what are some of the more advanced ideas to get more reliable and predictable outputs from the systems. And all of these ideas, right, contribute to making the systems more performant, but also kind of more reliable, which is an important aspect of working with these LLMs. So we're always measuring how good the performance is, but also how reliable those outputs are from these systems. And so this particular library, they do structure generation. It's a neat library, right? I've used this one, I've experimented with it, and they are claiming that using structure generation, this Phi-3 model from Microsoft achieves 95.5% accuracy, when it only achieves 86% without structure generation. So that's a significant boost in performance just by structuring those outputs and constraining those outputs. That's what structure generation is about, right? Constraining those outputs. And that makes a lot of sense because we end up using a lot of these tools to parse information, structure it, validate it, and so forth. And that helps a lot with creating more reliable systems. So it says also it beats GPT-4, which is the 3.5. So if you just use the proprietary APIs here of these models, you can still get even better performance by using tools that do structure generation. Don't sleep on structure generation. I think it's something that is going to be brought up over and over and over again. And as developers, I think we should pay close attention to the developments happening around structure generation or structured outputs, and even how to structure inputs as well. Next up, we have this announcement. No, I don't really track too much like the embedding space, and there's not a lot of news about embedding space, but usually when there is some announcement about an embedding model, and in this case an embedding multimodal model, I think it's always great. So here Nomic AI introduced this Nomic-Embed text embedding, which becomes multimodal. And so here you go, you have all the high quality unified embedding space for image, text, and multimodal tasks. There's a lot of interest in multimodal systems, and I think it makes sense that these efforts exist. And again, I really like that they are doing this work in public and opening access to these systems. I think it gives us more of an understanding of how these systems work internally, and we can leverage them for all sorts of applications. So this unlocks lots of capabilities, and so I'm always excited to see like new embedding models. And it says that it outperforms both OpenAI Clip and text embedding tree small. Having this multimodal system outperforming these individual systems, I think is also a great progress. Again, they make it open weight, and there's also more details about research and experimentation that they did. And it's a massive collaboration between a lot of like interesting companies as well. Next up, we have a set of courses. I'm always on the hunt for high quality content, educational content around AI and LLMs. So this week I found 3 interesting ones. This one is about tool usage with the Anthropic models. How to force JSON with tool use is really important for a lot of applications. Building a chatbot with multiple tools. So it's all about tool usage, right? And how you can use the cloud models for that. And there's a series of notebooks here. So I'll leave the link in the description if you're interested in that. The next course is from Cohere. So Cohere has released this set of cookbooks. They have all these different use cases, right? And I really like this, that they kind of categorize this into different use cases. They have RAG, they have search and embedding, agents. So you will see here that they have some agent cookbooks. So if you click on one of these, for instance, if you want to do multi-step tool use, you can click on that. And again, it's about tool usage in this case, which is one of the ideas and ways and how these models are being used today to combine LLMs with these external tools. And I think it's an interesting area, and it's an area a lot of people should be focused on and trying to take advantage of. And there's all these like React agents, right? And you can leverage LangChain for React agents, and how you can kind of develop the tools and build these really advanced agentic workflows, which a lot of the community is interested in. And I believe some of the ideas that they share here, they can be transferred to other models as well. So I don't think it's too important to be using like their models specifically. I could see they're using like Llama Index, they're using LangChain and so on. And so it should be easy to use other models. And I like that approach. The next course here is from Andrew Ang. It seems like every week Andrew Ang is releasing a new course. I like that. I love all of that. And I think, yeah, he's one of the best educators in the space, and he's doing all these collaborations with deep learning.ai and with a lot of founders, and where they share how to use some of these tools that these founders are developing. And in this case, it's LangChain, and how to build like single and multi-agent LLM application. It's all about the agentic workflows, how to develop agentic workflows. I think LangChain is starting to really heavily focus on agentic workflows, and I think that makes a lot of sense, especially with the tools that they have built and the ecosystem they have developed. And so this is an interesting course, right? It's a short course. I always take these courses. I learn a lot from taking these courses. They also take this approach where they build an agent from scratch, which I really like, and then kind of reconstruct it with something like LangGraph. And LangGraph is one of the main tools that folks are using to experiment with agentic workflows. And that's it for this episode of LLM News. Thank you so much for your attention, and see you on the next one.